Hey everyone, welcome to UBG Bytes. I'm Alex.
And I'm Jamie. Today we're diving into macOS Kauth Internals, the kernel authorization subsystem that's essential for security tools but often misunderstood.
Absolutely. If you've ever wondered how antivirus programs monitor file operations or how endpoint security works on macOS, Kauth is a big part of that story.
Let's start with the basics. Kauth was introduced back in macOS X 10.4 Tiger as a way to manage authorization decisions in the kernel.
Right, and the K in Kauth literally stands for kernel. It's a programming interface that lets kernel extensions hook into system operations and either authorize them, deny them, or just receive notifications about them, which makes it super valuable for security software. I mean, if you're writing antivirus software, you need to know when files are being executed, right? That's the beauty of Kauth, is how it organizes everything through what Apple calls scopes.
Ooh, scope talk. This is where it gets interesting, folks.
Jamie's our scope enthusiast. But seriously, scopes are just areas of interest for authorization. Think of them as categories of operations that your kernel extension might want to monitor. The most commonly used scopes are kauth scope vnode for file operations, kauth scope file OP for file system operations, and kauth scope process for process management. And what's really cool is how these scopes contain specific actions. Like within kauth vnode, you have actions like kauth vnode execute when a file is being executed, or kauth vnode wire file when a file is being modified.
So, how does a developer actually use this? Let's break down the key API call.
The main function you need is quite the listen scope. You pass it three things: the scope you're interested in, a callback function pointer, and some optional data.
And your callback function gets invoked whenever an event in that scope occurs. Pretty straightforward, right?
On paper, yeah. But in practice, you need to be careful. These callbacks are running in kernel context, which means if you mess up, you can crash the entire system.
Oof, I have been there, done that. Not fun explaining to your boss why your test Mac won't boot anymore.
I know the kernel is an unforgiving place. But let's talk about what makes the callback function interesting. It has to return one of three values: kauth result allow, kauth result deny, or kauth result defer.
And this is where the authorization part comes in. If any listener returns deny, the operation is blocked. It's a very security-focused model.
Exactly. So if you've ever tried to delete a file and gotten an error, even though you have admin rights, there might be a Kauth listener saying, "Nope, you can't do that." Which is exactly how antivirus protects itself from being disabled.
Speaking of security, Kauth has been at the center of some serious vulnerabilities over the years. Did you hear about that recent one? CVE year 2025, number 24,118?
Oh yeah, that was a nasty one. A race condition in the Kauth cred T credential handling. Basically, a thread's credential pointer could get corrupted during non-atomic updates.
Right. Joseph Ravichandran from MIT discovered that one. He even released a proof of concept showing how an unprivileged local attacker could trigger it by forcing frequent credential updates with multiple threads.
Apple patched it in January 2025, but it had a CVSS score of 9.8. That's as critical as they come. Just goes to show how powerful these kernel interfaces can be in the wrong hands.
For sure. There have been presentations at security conferences, like Objective by the Sea, showing how Kauth could be leveraged in different ways. Patrick Wardle from Objective-C has done some great work documenting this.
Didn't Wardle use Kauth in some of his security tools too? Like for monitoring process creation events?
Exactly. His blog posts about implementing Kauth listeners for BlockBlock are really informative. Shows both the power and the complexity of working with these kernel interfaces.
One important thing to mention is that Kauth is actually being phased out in newer versions of macOS.
Yeah, starting with macOS Catalina, Apple began deprecating kernel extensions entirely in favor of system extensions that run in user space. The replacement for Kauth is the Endpoint Security Framework, which serves a similar purpose but runs outside the kernel. It's part of Apple's broader strategy to improve security by moving code out of the kernel.
But Kauth is still widely used in the wild, and understanding it gives you great insight into how macOS security works at a fundamental level.
Absolutely. And for developers working with older macOS versions or maintaining existing security tools, Kauth knowledge is still essential.
We should also mention that beyond the public Kauth API, there's the mandatory Access Control Framework, or MACF, which is Apple's private KPI that offers even more powerful hooks.
Yeah, macOS is what Apple uses for their own sandboxing mechanisms, but it's not officially supported for third party developers.
I think that covers the essentials of Kauth internals. Any final thoughts, Jamie?
Just that I find it fascinating how these authorization systems reflect Apple's security philosophy, providing hooks for monitoring and policy enforcement while maintaining tight control over the platform.
Well said. And that's our deep dive into macOS Kauth internals.
This has been a blast. Thanks for breaking it all down, Alex.
Always a pleasure, Jamie. And thanks everyone for tuning in to UBG Bytes.